is a unit on significant figures. Some textbooks call it digits. On significant figures, the reason we do this is it shows how good your measurements are. So the reason behind this is to show how good your measurements are in a lab situation. You don't want to give a false sense of precision, which is not there. For instance, if you have 1 divided by 3, your math teacher will say 0.3 repeating, or 3, 3, 3, 3, 3. Okay? Something like that. So if you do that, and you write all these digits down, that means you have a really good measurement. But remember how we read our scales. You round it to the very first, you round it to the one smaller than your unit is. So if it's 1, that means it could be anywhere between 0.5 and 1.49. If it's 3, it could be anywhere between 2.5 and 2.4999. So it's 3.4999. So that it can be a wide range of things. Having it this far is leading a false sense. So what we do is we got to count how many significant digits there are and round your math, round your answers to that number of digits. Interesting little trick I've learned is something called the Atlantic-Pacific rule. So you do a little U.S. map here. Friendly Michigan's waving at you. And West Coast, kind of goes like that. Texas, which we don't like. Florida. So you have something like that. And New England looks like that more. Okay, so we got United States. This is the Atlantic Ocean, and A stands for absent. This is the Pacific Ocean, and it stands for present. You put your number, or think of your number being in the middle, in the heartland, and you count digits, ignoring zeros, from one goes to the other. For example, if you have this right here, you do not see any decimal point. There's a decimal point absent. So you start from the Atlantic side, ignore zeros until you hit the first non-zero number, which is the 5, and count. This would have 2 significant digits. If you have this situation, it's a bigger number, but you still do the same rules. Absent, ignore zeros until you hit the first non-zero number, 5, and count. This has 2 significant digits. The zeros, the only purpose for the zeros is to serve as a placeholder to tell you the difference between 4,500 and 45 million. If there are something called embedded zeros, decimal points absent, so you ignore zeros, so you ignore these 2 zeros right here, and then you count the digits after that. That 0 counts because it's inside, it's not just a placeholder. So it's 4. You have 5,000, ignore zeros, 1. That's if it is absent. If the decimal point is present, then you start on the left-hand side. So you have 0.043. You notice there is a decimal point, so you start on the Pacific or the present side. Same rules, ignore zeros until you hit the first non-zero number and count 1, 2. 0.000103. Ignore zeros, 3 significant digits. If you have this situation, 4.003, there's a decimal point present, even though it's bigger than 1, it's not starting with a 0, you still do the present side. In this case, the very first number is a non-zero number, so you don't ignore anything, you count 4. If you have this situation, still follow the same rules, the decimal point's present, you start over here, ignore zeros, and you count every number after it. In this case, 3. Those zeros are there to show how good a measurement you took. There were 2 additional zeros, which means you're guessing at the nearest 10 thousandths. Over here, if you have this number, the decimal point is present. So you start on the left, and you go there. The very first number's not a 0, so you ignore nothing, and they all count. The only reason that decimal point there is to tell you that you start on the present side. Now, if you add or subtract digits, the math, the reasoning for this, if you add numbers like this, or subtract, you just add and subtract. There are rules that you use if they are not the same size, but usually in chemistry when we add or subtract, we're going to be adding, subtracting numbers that are like grams or milliliters. In that case, we're going to use the same instrument. We're not going to use a bathroom scale one time and a electronic balance another time. We're not going to use a beaker one time and a graduated cylinder another time. We're going to use the same instrument to do our measurements. So in chemistry, it might be different in physics, so you just got to deal with that. If you add or subtract, you just add or subtract. No rounding. The difference is when you multiply or divide. If you multiply or divide, things change because you are moving the decimal point when you do that. Here, the decimal point is lined up, it's not moving around. If you do division, say, up here, if we have 1, let's say 2. 2 divided by 3. On your calculator, it will say this. Do not copy down your calculator. How many significant digits is this 2? Well, there's no decimal point, so it's absent, so it's 1. How good is this 3? It's 1. If this is 1 and this is 1, the weakest link tells you which one to stop at. 1, 1, so you count from the left to 1 significant digit. So your answer, if you have 2 divided by 3, you report it as 0.7. And let's label it, say this is meters, and that's seconds. Meters per second. If you have 2.00 meters divided by 3 seconds, you still have 0.666666666. This is, there's a decimal point present, so you start here, 3 significant digits. There's no decimal point, so you start here, 1 significant digit. What is the worst type of measurement? Well, the 3 is. It's only 1 significant digit. So if you have 3 and 1, the lowest score wins. 0.7 meters per second. If you have 2.00 meters and 3.000 seconds, 1, 2, 3, with point present. 1, 2, 3, 4, 5. 3 is worse than 5, so your answer is going to be 0.667. 3 significance long. You notice how well your answer looks compared to that 2. They should be in the same size range. So if you have 2.000000 meters, 3.00000000 seconds, 1, 2, 3, 4, 5, 6, 7, significant digits there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's smaller? 9 or 7? 7 is. So you're going to have 7 significant digits, and that just tells you where to round off. 1, 2, 3, 4, 5, 6. The next one's a round off, so it's going to be 7. So essentially, the significant figures when you're multiplying and dividing tells you where to round. And you follow the regular rounding rules. So where to round your answers to show how good your measurements are. So significant digits are there to help you round. Please do not copy down your answer key. Don't copy down the calculator when you're doing these things. That concludes this lesson on significant figures.